The objective of this lesson is to solve real-life situations about angles using prior knowledge. In previous lessons, students learned how larger angles can be decomposed of smaller angles, and smaller angles can be combined or composed to make larger angles. Students also learned that a right angle is 90 degrees and a straight angle is 180 degrees. In this lesson, students read real-life problems that involved angles with degrees. No protractors were needed, only reasoning skills along with addition and subtraction. However, if some students need to use a protractor to draw the visual angles, they may do so. Here is an example that the students may have worked on in class. Dawn has a sprinkler that rotates in a 40-degree angle. The area the sprinkler should cover spans 135 degrees. How much increase is needed for the sprinkler to cover the needed area? There are different strategies for solving this. One recommended strategy is to model the problem by sketching the angles in the problem. Let's use this strategy and sketch out the angles by starting with the area that the sprinkler needs to cover, which is 135 degrees. We know that Dawn's sprinkler already covers 40 degrees, so we need to decompose the 135-degree angle with a 40-degree angle. We need to figure out how many degrees the other angle is. We can find it by using this expression, 135 subtract 40. The other angle measure is 95 degrees. The increase needed to cover the 135-degree space is 95 degrees. Let's try another problem. Hero's map tells him to make a 144-degree right turn at the first sign, and then a left turn 1/3 the size at the second sign. How large of a turn should he make at the second sign? As with the first sprinkler problem, let's sketch out the angle to make sense of the problem. We know that Hero will make a 144-degree turn. So let's sketch out an angle that is 144 degrees. The second turn will be 1/3 the size of the first turn. So our 144-degree angle will need to be decomposed into thirds. 144 divided by 3 is 48. So there will be 3 angles with 1/3 of the angle measure to be 48 degrees. It may not be necessary to make the other 48-degree angles if the answer is already known. We can write the equation as 144 divided by 3 equals 48. Now to answer our problem. Hero will be making a 48-degree turn at the second sign. The objective for this lesson was to solve real-life situations about angles using prior knowledge. We met this objective by decomposing angles from real-life problems.